Mic on.
We will start in just a couple more minutes. I'm just kind of letting people kind of trickle in. Um, like I just typed in the chat, there's a chat bar. If you scroll down, um, whether on your phone or on laptop or computer, um, use that chat to ask me a question since we don't have anything vocal. I'll be checking on it periodically. There is a time delay between the video and the questions I will get. So just keep that in mind, but I will take as much time as I need to make sure I answer every question possible. We'll start here in just a few.
Mic off. Mic on.
All right, I'm gonna go ahead and get started. So, thanks for joining us, guys. I really appreciate y'all coming to the live stream for this. Um, Sorry that we couldn't do it live. I thought we were gonna have the exam on Tuesday for some reason instead of Monday, but nevertheless, we'll make sure to get it done. So, today we're going to be going over the problems that you will most likely see similar to on exam 1 for statics. So I'm going to be going over the problems 2.35, 2.103, 3.3, 3.108, and 3.114. I did one more extra problem than Jackson just because I thought it'd be kind of helpful to y'all. So again, if you have any questions, there is a chat bar. Just type your question. I should see it, and I will try to answer them as fast as I can going through it. Alright, so to start it off, we're going to start at problem 2.35. We are given that alpha is equal to 35 degrees, and they ask us to find the resultant. So we go to the free body diagram. This is going to be like a hook hanging from a ceiling with 3 different cables, ropes, or anything tied to it. And so we need to find the resultant of those 3 forces. So I went ahead and made my coordinate plane so that all my forces going down are positive in the y direction, and then positive x as normal. Okay? So, to start it off, we're just going to do the sum of forces in the x and y. So we have the sum of the forces in the x direction is equal to 0. I'm going to state that it's positive to the right. We have 100 newtons. I'll zoom out so you can kind of see this a little better. We have 100 newtons times the cosine of 35 degrees, because that's at an angle, plus 150 newtons cosine of 65 degrees, and the cosine of 65, all that is 30 plus the alpha, which they gave us alpha to be 35 degrees, minus 200 newtons cosine of 35 degrees, all equal to 0. And now sum of forces in the y direction equal to 0. I'm stating that it's positive going down. We have 100 newtons sine of 35 plus 150 newtons sine of 65 plus 200 newtons sine of 35, all equal to 0. Solving both of those equations out, I'm going to say them as Rx and Ry. Solving those, we get Rx to be negative 18.5 newtons and Ry to be 308.02 newtons. Now those are component forms in the resultant, so we need to get those into a final resultant force. So to get that, we need to add the sum of squares of Rx and Ry. But before that, we need to find the angle that they're going to be going at and that resultant. So to kind of elaborate that, so we have our basic little graph of our components. We have Rx going this way and Ry going this way. This is 18.5 newtons and 308.02 newtons. Our resultant is going to be in between those two, resultant total. And the angle that they're going to be going at, I'm going to label as alpha 2. So to get alpha 2, we just take the inverse tangent of Ry over Rx. Okay, so inverse tangent of 308.02 over 18.5. I'm leaving them as positive because the number would come out as a negative degrees, which just means it's below the horizontal axis, so we already know that kind of makes sense. I'm going to, undo that. How about I add a page instead of deleting a page? Okay, so solving that out, alpha 2, we get 86.56 degrees. Now remember, in your calculator, have your calculator set to degrees, not radians. That will be a change. I got a question that says, why did we use tangent? The reason why we use tangent is just because if you look at this from like a basic triangle standpoint, we have sine and cosine right here, cosine being on the top base and then sine being right here. So our resultant, the angle for the resultant, will be the tangent. This is the tangent line, or the hypotenuse. So that's why we use inverse tangent. If that didn't explain it well, you can throw out another question. I can try to go more in depth. Okay, so now that we know the angle, we can do the resultant as the sum of squares, or we can do the resultant as r is equal to ry over the sine of alpha 2. So we can use law of sines at this point to solve for a resultant instead of doing the sum of squares. Both ways should work, but if not, just do it the law of sines ways and it will work out just fine for this problem. So we have 308.02 newtons all over the sine of 86.56 degrees. We get a total resultant force of 308.6 newtons. So pretty close to the Ry value. Okay. I'll do a slight pause just to see if y'all have any questions over how I got any of that. And this is just the first trial doing this live stream like this. We might do it differently next time if we have to do it virtually instead of live in person. So just kind of bear with me, but I appreciate your patience. Okay. So far, I'm not seeing any questions. I'm going to move on, but if I do see a question about this problem as I go further, I will go back to it. Okay. Our next problem, again, is Chapter 2. It's problem 103. So this one is going to be a basic, it's just like a hot air balloon, but instead now it's going to be like a hanging weight. So this problem is like a box with like a motor that's being suspended from the ceiling. And we need to find the tensions of 3 cables or the weight. And so for this specific problem, we do know the tension of tension AD, and we need to find the weight, tension AB, and tension AC. Looks like I do have a question here. Is the resultant formula always R is equal to Ry over the sine of that alpha? Or will it sometimes be R is equal to Ry over cosine alpha? So what I did for that instance is I used the law of sines. So that's I used Ry and sine. So if I was to use the cosine, I'd have to use the Rx over cosine alpha. So whichever one you use, if you use cosine, you use Rx. If you use sine, it's going to be Ry. Hopefully that kind of clears that up. Okay, so for this problem, again back at 2.103, we need to find the weight, tension AB, and tension AC, and we do know tension AD to be 924 pounds. Okay, so we draw our diagram, and we start evaluating it. So for the diagram, we have the tensions at A, so A is being suspended, so right here at the O, these access points is the ceiling, and the weight is being below the ceiling. Our point of interest is A, and we're going up to the ceiling. So we're starting at A, going up. That is a really good little key point to note when doing this problem, that whatever point has all three tensions or anything acting on it, whatever has the most acting on it, that is going to be your point of interest. So for this case, it's point A. If we had the hot air balloon and it was on top of the axes, so if the hot air balloon was actually up here, point A was up here, it'd be going down from A to C, or B, or A, or D. So always keep that in mind. Whatever you write it as, so here, the question asks tension AB. A is the first letter, A is our point of interest, going up. I've seen that mistake happen a lot, so just make sure we had to clarify it. Point A is our interest. Okay. So, I'm going to try to get the picture in view while doing this. So, let's just evaluate. We have tension AB. We're going to evaluate it. So, in the X direction, B is going at 28 inches. In the I direction, it's going up 45 inches in the J direction, and 0 in the K direction. Now we need to do lambda AB, which is the sum of squares. So we have 28 squared plus 45 squared plus 0 squared. Now if you know about the sum of squares, whether you have a positive or negative in it, it doesn't matter. It's going to come out positive regardless. So doing lambda AB, we get 53 inches. So that means that every one of those values is going to be divided by 53 inches. I'm just going to write it as one big division bar. Okay, now let's evaluate tension AC. Make sure you still see it. So tension AC in the X direction, we have 0 inches in the X direction, or I. We have a positive 45 inches again in the J direction, and this time we have a negative 24 inches in the K direction. Lambda AC is equal to, again, the sum of squares. We have 0 squared plus 45 squared plus, I'm going to put negative 24 in here, but it's going to come out positive regardless. So doing that, we get 51 inches. So all this is going to be divided by 51 inches. And for the off chance that I'm going too fast, again, you can ask questions. But if I am going a little too fast for you, don't worry. I am recording this right now, and it will be posted to the channel as normal. So don't worry if you don't catch anything or you don't get your question asked. You'll be able to come back to it later. All right, so let's evaluate tension AD now. Just see, make it to where you can see it still, 18 inches. Okay, so in the X direction, we have a negative 26 inches in the I. Again, positive 45 inches in the J, and a positive 18 inches in the K direction. Lambda AD is equal to the sum of squares of negative 26 squared plus 45 squared plus 18 squared. This comes out to 55 inches. So all of tension AD is going to be divided by 55 inches. Okay, so now we have our evaluations. We need to do our sum of forces. So sum of forces in the X direction, all equal to 0. Normally this is where you'd state your coordinate plane, saying like it's positive to the right or positive up. This is in 3D, and they gave us our coordinate plane, what's positive and negative, so we don't necessarily have to do that. But if you really wanted to and be more in detail, you could say that's positive down to the right. So to do this, all you gotta do is you're gonna take your I values associated with your tensions. So we have 28 over 53 tension AB plus 0 over 51 tension AC and negative 26 over 55 tension AD, all equal to 0. Continuing on, we're now going to sum of forces in the y direction, equals 0. We're going to state it's positive going up. We have all of these are going to be in 45, so just the division that's going to make the difference. Over 45 over 53 tension AB plus 45 over 51 tension AC plus 45 over 55 tension AD minus the weight is equal to 0. Now, keep in mind that for this diagram, this weight is hanging. Due to gravity, it's going down. So we have a negative weight because we said our y is going positive vertically up. Okay. Alright, continuing on, now we do the z. Forces in the z direction equals 0. We have 0 over 53 tension AB minus 24 over 51 tension AC and 18 over 55 tension AD is all equal to 0. Now, we were given that tension AD is equal to 924 pounds. Okay, so that means that we can add in the value for tension AD. So we'll take some of this off so we can factor that in. So all that's times 924 pounds, 924 pounds, and 924 pounds, all three. Don't forget the weight minus W, all equal to 0. Okay. So that is going to be our full equations for the sum of forces in the x, y, and z direction. Now we have three unknowns and 3 equations. So we need a matrix. So this is going to be a 3 by 3 matrix times a 3 by 1 matrix. So a 3 by 3, and I'm using the inverse method of a 3 by 1. You can also use what's called a reduced echelon form of an equation, or REF, which just makes it a, I believe it's a 3 by 1? 4 by, yeah, 4, no, it'll be a 3 by 4, I'm sorry. But I'm not going to go into detail that. If you know how to do it, you know how to do it REF way, or you can just use the inverse method that I'm going to use. So I'm using the inverse method. I'm going to go ahead and pull that down and make me some more room. And I'm going to cheat a little. I'm just going to copy and paste this down right here because that makes it a whole lot easier. Okay. Now we need to move our knowns all around. So we know the 26 and tension AD portion, the tension AD portion. So all of the tension AD is actually going to come to the other side of the equation. And we'll move that there. This will be 0, 0. That will finish that matrix. Inverse of this guy. Okay, and now I know just right there I kind of went kind of fast because I copy and pasted, so I will give you just a minute to write that down. But basically, we just take what we do know everything that we do know has to go onto the other matrix, the 3x1 matrix. Whatever's unknown has to go into the left 3x3 matrix. So now we have 1 unknown, 2 unknown, 3 unknown, and our 1 knowns. Yes, the signs do change. We have this to be positive, negative, and negative. That's a good catch. I just copy and pasted, so I didn't quite catch it. So good eye. Yes, when you move it over, it's just like when you move over anything to the other side equal signs. If it's subtraction, you add it. If it's addition, you subtract it. So yeah, the signs do change. Okay. If you still don't have a good idea on how to put the matrix into your calculator, go back to the channel. There is a video over TI-84 Plus, how to put a 3x3 matrix in. It's like I think a 4 to 6 minute long video. I go through step by step on how to put it in. For the right hand portion, you'll quite literally just type 26 divided by 55 times 924, and you'll do that for each of those three. Not the actual value, but like the steps. So moving on, this comes out with tension AB is equal to 826.8 pounds. Tension AC is 642.6 pounds, and the weight is 2,025 pounds due to this matrix. Now the actual one in the book values is 2030, and I'm just going to assume that to be probably a rounding error. Everything that I've used is without rounding, so this should be right, but this will get you a full credit of the problem anyway. If you notice, so when the answers came out as tension AB, AC, and the weight, that is because of how we set them up in the RE matrix. So whatever's in the first column, second column, and the third column is your first answer, second answer, and third answer. And that is it for that problem. More than likely, you'll see a problem on the exam that's going to be either just like this, where you have a known tension, you have to solve for the remaining 2 tensions and the weight, or you do know the weight and you have to find all 3 tensions. Either way, it's going to be the exact same format. All that changes is where you put your knowns. Alright, again, I'm going to move on, but if I'm going to watch the chat, if there's a question over this question I just went over, I will go back to it. Okay, so for our next problem, chapter 3, this deals with moments. So we're going to go over 3.3. They gave us that a force at C is going up vertically of 200 pounds. So if you look at the picture in your book, this is basically just a little bar with a nail that's at point C, and they're trying to pull the nail out so they can remove the bar. And it has some tension at P, or at A of tension P. They ask us to find the moment of B due to the nail, find the force P when alpha is 10 degrees, and find the smallest P that has the same moment of B. Okay, so to start off, we're going to start off with the first one. So we're going to do the sum of the moments about B is equal to 0. I'm stating that it's positive counterclockwise. So we have a negative 200 pounds times the 4 inches is equal to 0. The way that I do my moments is I take the force times the perpendicular distance. I know that when you look at the book, it says a moment is equal to the R times F, or R cross F. So they basically say the perpendicular distance times the force. I just do it the other way around. Either way, it's the same. I like doing the force first just because it helps you see it better. But so continuing on, that's all we have to solve for. So the moment about B due to C. So I'm going to say due to the nail is equal to negative 800 pound inches. Now that's not pound per inch, it's being multiplied, so it's pound inch. Now you see that it's negative, so that means that my assumption of counterclockwise being positive is wrong. That it's actually going to the up and to the right, so it's going clockwise. The value, the actual negative sign really doesn't do anything. It just tells us direction. So basically, what it means is that the moment about B to C is going clockwise. That's all that states. All right, continuing on, solving for part B. I'm going to go ahead and find a value for, I'm going to make another angle right here being theta. It's kind of hard to see, but theta. I'm stating that theta is equal to 70 degrees minus alpha. And we have 70 degrees. They gave us alpha, which is 10 degrees. We get theta to be 60 degrees. The reason why is because I'm taking a moment using P at this angle about B. That is the whole reason why I did that. If you take it about alpha, it's going to be a little bit harder because now you're referencing the horizontal axis rather than the axis plane that it's accounting for. So this is the easier route. You can do it with alpha. It's just going to be a little bit more tricky. So now that I know that angle, do the sum of the moments about B again, equal to 0. Again, I'm staying consistent. I'm saying that counterclockwise is positive. So I'm going to have the moment itself, because now I know the moment, right? I just found the moment of negative 800 pound-inches. So I have negative 800 pound-inches is equal to the negative P sine of 60 degrees times its perpendicular distance, which is 18 inches. Okay. The reason why P is negative is because that rotation is still going clockwise about point P, about point B. If the arrow was going up and to the left, it would be counterclockwise, making that positive, but it is negative. Okay, so now I need to solve for P. I get force P to be negative 800 pound-inches, all divided by negative 18. I'm going to rewrite this, 18 sine of 60. I just moved that 18 in front. I get force P to be 51.3 pounds. Okay, we got a question here. Is can we just always put the moments as counterclockwise and have our answer indicate whether that is correct or not? Or do we need to conceptualize and take the time assuming it? No, so the basic assumption for a moment is counterclockwise positive. Most engineering aspects in the real world, they associate counterclockwise as positive. That is why I'm stating it positive. But if you already know, based off the problem, like if you look at the problem and you know that that moment is going to be clockwise, and you know that's probably going to be a positive value, you can state that it's positive clockwise. But when you're doing the analysis, you have to be sure that you visually state that you're saying that clockwise is positive rather than counterclockwise being positive. So it's all about how you state it. So you can say counterclockwise positive or clockwise positive. Doesn't matter. Just make sure you stay consistent. Okay, and for the last part, we need to find P minimum about moment B. So P min, we have our moment about B is equal to our P min crossed with the R of a B. So we have the negative 800 pound-inches is equal to P min times that perpendicular distance, which is P min is also negative, I'm sorry. So it's negative P min times the 18 inches. P min is equal to negative 800 pound-inches all over negative 18 inches. This means that the inches will reduce out. We just get pounds. We get P min to be 44.44 pounds. Okay. That one is it for 3.3. It's pretty straightforward. You just have to know that association of changing that degree, that angle that you're assuming from, not from alpha, but instead from theta, just because it makes it easier for part of the actual figure. I'm going to go ahead and continue on. Again, if you have any questions, I will go back to it. Alright, next problem on our list, 3.108. 3.108, they give us a plate 6 inches by 12 inches. They're asking us to find the resultant of the 4 loads and the 2 points at which the line of action of the resultant intersects the edge of the plane. Okay, that was a lot of words. If you get any kind of confused about what they're asking us for, all they're asking us to do is to find the line of action. So we need to find the resultant force and the line of action at which they cross in the plate. So we have all of these forces going in all these different directions. So we have majority of the forces going up and to the right, and we got 2 going down to the left and 1 going down. So most likely our resultant being the main 3 forces being up here, we're going to have a resultant going up and to the left more than likely. And then they ask us to find where on the plane in the x and y direction that resultant is going to lay on, so that line of action. I just had another good question come up. So if you do not have a YouTube account and you're not able to actually be involved with the chat, you can send me an email. I have my email pulled up right here in front of me. So if you have a question and you can't chat it on the stream, feel free to email it to me. I'll hear it go off and I'll be able to turn and answer the questions. Okay. Trying to move stuff along here. Come on. I love it when technology is not working. Okay. So continuing on. So we have our plate. These 2 forces at B and at E are parallel. We have 40 pounds at A, 50 pounds at B at a 45-degree angle, 20 pounds vertically at C, and 50 pounds also at a 45-degree angle from E, because those are parallel. Okay, so to start off, let's find the resultant. So we do sum of forces in the x and y. Sum of forces in the x equal to 0. I'm stating that it's positive to the right. We have, pull it down so you can see it. We have a negative 40 pounds plus 50 pounds minus 50 pounds equal to 0. So in the x direction, say is Rx is equal to a negative 40 pounds. 40 pounds. Okay. Sum of forces in the y direction equal to 0. Positive going up. We have 20 pounds plus 50 pounds sine of 45 minus 50 pounds sine of 45 equal to 0. Just like how those reduced, these reduce, we get Ry to be 20 pounds. Okay, now we need to find our resultant. Our resultant is going to be the sum of squares of rx squared and ry squared. Now, I did just get an email for a question. Let's see. The question is given that, or the question asked is, do we think there's going to be any 3D moment problems for this exam? No, he's not going to give you any 3D moment problems. That is a lot to work with for the given amount of time that you have, which is only about an hour and a half. You're going to get about 4 questions for this exam, so having a 3D moment problem is just going to be taking too much of your time for this exam, so he's only going to give you a 2D moment problem. Further on into the class, he might give you a 3D moment problem dealing with something like multiple tensions on a pulley in 3D, but more than likely he will not, just because it just takes too much time to analyze. Okay, so going back, we have take a negative 40 squared plus 20 squared. Our resultant force is going to be at 44.72 pounds. Okay, we also need to find the angle that it's going to be going at. So I'm going to find it as alpha is equal to inverse tangent of ry over rx. So inverse tangent of 20 over negative 40. This is going to come out to a negative degree. So you really actually don't need the negative sign, because you're kind of taking like the absolute value, because it's just a degree. We kind of already know what it's going to be doing based off of our x and y coordinates. So we get it at 26.6 degrees. So at angle 26.6 degrees. Okay. Now part B. Actually, before part B, there's one more thing we need to solve for in this portion to answer part B, is that we need to find the moment. We could take a moment about any different point. It does not matter, since this thing is symmetric. I'm going to choose to take a moment about C, but you can take a moment about any different point. Okay, the question that we just got is, are those canceled out because they are a couple? Yes, because those forces were parallel, and due to our sum of forces that we did in our analysis, that they do reduce out. So yeah, they are a force couple. Okay, so let's take a moment about C. I'm doing the sum, by the way. I'm saying counterclockwise is positive. Kind of zoom out so you can see this, if I can get it. Yeah, there we go. We have a negative 50 pounds times cosine of 45 in the I direction and positive sine 45 in the j direction. All that is being multiplied times perpendicular distance of 6 inches, all equal to 0. We get a moment about C to be negative 213.13 pound inches. Now that's not something that they directly asked us for, but we need it in order to find parts B and C. So for part B, they're asking us to find the x-coordinate that the resultant line is going to be on. So the equation is going to be mc is equal to the, not p, 20 pounds times the x direction. Now the reason why that I chose to 20 pounds is though we're taking a moment about C, and this is going to be the x direction. So we already found the moment about C, and we have the 20 pounds going to be counterclockwise. But our x direction, so we're at C, the only direction we can go is to the left, so it's going to be negative, if that makes sense. So I'm going to put a negative out in front. Now that I know the moment, it's negative 213.13 pound-inches equal to negative 20 pounds times the x direction that it's going to be going in. Solving for x, we get x to be 10.61 inches the left of point C. And for value C, double checking something real quick on the chat. For point C, same equation, MC, but now we're going to take the y consideration. So we have a 40 pounds times the y direction. So if you look, we have going in the y, the perpendicular distance for the y direction, and then the perpendicular force is going to be the 40 pounds. So we have the 6 inches, 40 pounds, taking a moment of consideration about C. So C, for the y direction, at C can only go down, so it's going to be a negative value. So I'm going to put that out in front. So we get negative 213.13 pound-inches is equal to negative 40 pounds times the y direction. Solving for this, we get y to be 5.3 inches below C. Do make sure that if you have a problem just like this, that you say which direction it's going about your point of interest. So we're pointing at point C, so it's going to the left of C and down of C. Okay. So far, I'm seeing no questions. I'm kind of letting the video kind of catch up though, but again, any questions, feel free to ask it and I'll come right back to it. Okay, very last problem, 3.114. 3.114 is just a simple frame. They gave us a moment of 80 pound-inches, and the moment is at A. They ask us to find the resultant and locate the points at where the line of action of the resultant intersects lines AB and BC. So let's first, we'll just worry about the resultant, then we'll worry about the line of action portion. So part A, let's find the resultant. So to do that, we're going to take the sum of forces again in the x direction equal to 0, going positive to the right. We have a negative 40 pounds plus 25 cosine of 60 is equal to 0. That comes out to an Rx value of negative 27.5 pounds. Sum of forces in the y direction equal to 0, positive going up. We get negative 10 pounds plus 25 sine of 60 equal to 0. We get an Ry value of 11.65 pounds. Okay, now we can find a resultant being the sum of squares of Rx squared plus Ry squared. We get a negative 27.5 squared plus 11.65 squared to be 29.9 pounds. Now we need to find that angle that's going to be going at. I'm just going to say is alpha is inverse tangent of Ry over Rx. We get an inverse tangent of 11.65 over 27.5. Alpha, it comes out to 23 degrees. So our resultant is 29.9 pounds at an angle of 23 degrees. Alright, And I just did get a question. The question asks is, how do we know where the resultant is located? Are we going at, for question 3.114 or what was it, 3.108? Either way, to know where the resultant's occurring at, just like we did in 3.108, is we take that evaluation of our moment about C in consideration of the X and Y direction. So if we print at C, we can only go left in the X direction or down in the Y direction. And then for this problem, 3.114, go away. For 3.114, we're actually just about to go over what the direction is going to be. So just bear with me, and I'll kind of show you step by step on how the location is, because that's what the second part of the question asks, as to locate the points. So for part B, oh, we got another question here. It says, when finding alpha, why'd the negative sign in front of the Rx go away? Is it because we flipped the 2 in the formula, or does it not even matter? So for finding alpha, you're asking about why the negative value went away at Rx. The reason why is kind of what I said in the other problems, is that all it's going to tell us is what direction from the horizontal or vertical axis that we're referencing from. So in this case, that we kind of already know it's going to be doing, but basically is that if we're looking at AB and BC, going this direction, the angle that it's been going at, I'm stating it from what would be the vertical direction. So from BC, it's going to be going out this direction. So in which case, it could be considered negative, but it's just kind of consideration. But the really good way to know that is when you find the X and Y location points of the resultant, then you're going to be able to know that angle and like kind of understand how it's going at. So just bear with me. I'm going to go over that real quick of the directions of which they fall onto the diagram, and then I'll go over how that angle works. So to find the location, we need to take a moment. I'm going to take a moment about point B, just because it gets rid of my more complicated value. So the sum of the moment about B equal to 0, counterclockwise being positive, we get 80 pound inches plus 10 pounds times the 12 inches perpendicular distance minus 40 pounds times its perpendicular distance of 8 inches equal to 0. This all solves for the moment about B to be negative 120 pound inches. Okay, that's not something we need to actually solve for. They didn't ask for it, but we need that value. So now we can find the location in the X direction. So we take our moment about B is equal to our resultant Y times that X direction. So we get negative 120 pound inches is equal to the 11.65 pounds times its X direction in inches. We get an X value, which in this case is going to be negative, of 10.30 inches. So that's going to be like a negative value. Let me write this a little better for y'all. X is going to be equal to a negative 10.30 inches. So that means is that I was looking at point B. It said it's negative 10.3 inches, so it's to the left of B 10.3 inches. So you can leave it that one as negative. So that's left of B. Okay. Now location in the y direction, we have our moment about B is equal to our rx direction, our force rx, and the y. Perpendicular distance of rx would be y. So again, we have negative 120 pound-inches is equal to our negative 27.5 pounds times y. Now this is going to be a positive value when you actually get the number to come out, but we know that we cannot actually go positive because of our diagram, is that it'd be up here off of the entire diagram, so that's not actually going to work. So we know it has to go down. Solving that out, we get y to come out to a 4.36 inches, and that's going to be below B. Again, the reason why, even though it was positive, we had to go below B, because we cannot go above the diagram, we cannot go off of our diagram. So to help kind of visualize of what this is doing, we have our diagram. We have point A, B, C. We have our x direction. I'm going to label this as x. And we have our y direction. I'm going to put this arrow right here. And this would actually continue on. So the resultant is actually going in this direction. So we have 10.3 inches and 4.36 inches. So basically that says from here to here is 10.3 inches and 4.36 inches from point B to there. And then this is our resultant. That kind of helps you kind of visualize what it's doing. So now that actually kind of helps us with our angle that we said right here or right here, just depending on which way you're looking at, of that 23 degrees. Okay, that is all that I've got. Good luck on the first exam, guys. I'm sure y'all do good. Y'all are asking all the right questions. Y'all look like you're doing pretty good on it. Again, if you have any questions, please feel free to email me. I'm going to be available all day today to answer any questions, and as well that this video is recorded and it's going to be posted on the channel here shortly. So that is it. Thanks for joining, guys, and I will see y'all next time.